Okay, so looking at number one, I think we did okay with number one, trying to figure out the graph of number one. So I just want to, let's see here, I'm trying to think about how to say this. So, you should have been able to graph it by at least, you could have let x equal, hold on, let me make sure my pen's writing. I could let x equal 0, since all these graphs go through the y-axis, and see what y equals. So when x is 0, y is equal to -2. So I need to look for a line that has the point 0, -2. And then maybe I can use the x-axis when y equals 0. I could substitute y with x and see what x is equal to, or y with 0 and see what x is equal to. So that would be 3x, 0 is equal to 3x minus 2 when I let y equal 0. Okay, so what I'm trying to do is here, I'm trying to find 2 points that would be on this line and verify it here. So if y is equal to 0, add 2 to both sides, so that means 3x would equal to 2, and x would equal to 3/2, or 1.5. So when I look at B, I see that when x is 0, I'm at -2, 0, -2, and when y is 0, x is at 1.5, x 1.50. So this is the correct graph. Now, when I was going over this, preparing for this class, I realized I think I got a little bit ahead of myself when I did problems, when I gave you problems like this, okay? We covered slope-intercept form, y equals mx plus b, and you looked at using y equals mx plus b in our assignment in our lesson to graph, but we didn't look at it as far as, okay, given 2 points or something, write the equation. And I've got a couple of those in there. So is that right? Did you guys find yourself scratching your heads when you got to like 19 and 20? Like, did we go over this? So, can somebody give me a yes or no? Okay. Okay. So we didn't go over it in algebra, but for my 2 geometry students, we did. All right, but in algebra, we didn't. So I got a little ahead of myself because this is what we're actually going to have to do this in assignment 5 or chapter 5, these type of problems. So I'm going to go ahead and go over them today. And I may take them off the test. I'm not sure, but depending on how comfortable, because you're going to have to do it eventually. I mean, this is, those problems follow what we're doing next. So we'll go over them and we'll go from there. Y'all let me know if you feel comfortable with them, or if you'd like some more time when we get into chapter 5 to see them again. But the reason I say all that was because, we looked at how we could, you guys did fine with number 5, but I'm using it, number 1, but I'm using it for to make some points. So I showed where you can make 2 points and figure out where those 2 points are for which, the proper line. But, and here's where I'm going to add to that based on what I just showed you with 1920. This equation is in slope-intercept form. Remember your slope-intercept form is y is equal to mx plus b. Okay, so the coefficient of x is your m, slope. Remember, that's the slope. M represents the slope. So in this equation, my slope of my line is going to be 3. And then remember, this is your y-intercept, which we call b. And that's a number, -2, that's a -2. So another way that I could have found the proper line in this graph was just to look for a line that had a slope of 3 and goes through the y-axis at -2. So if I did it that way, I can eliminate this one because it doesn't go through the y-axis at -2. That's what this is, the y-intercept. C maybe, B maybe, but not A and D. Okay. From there, between these 2 lines, I would look for a slope. All right. And I know we talked about verticals and horizontals. We may not have talked about this, Annalise. So you might want to make note of this, but I know Emily and Andrew have heard this. When a line has a negative slope, they fall from left to right like this one does. When a line has a positive slope, it rises from left to right. Okay, so again, trying to find the correct graph, I can eliminate this one because the slope is a positive 3. But I could also count. I could say, okay, I'm going down 1, 2, 3, and one more, and I'm back on the line. That's a negative slope. This is a positive slope. So I'm at B. Okay, so if you took all that in and understood it, and it's going to stick with you, that's great. But again, if all else fails, just make 2 test points. Okay, like we did at the beginning, make 2 test points and see if those points, see which line it contains those points. So I could say, all right, I'm going to let x equal 0 when x is 0, y is -2. I'm going to let y equal 0 when y is equal to 0, x is equal to, it was 3/2. Okay. All right, so I just threw a lot at you. Any questions on that or comments, like you just blew me away or anything? All right, number 2, find the slope of the line. All right, we've learned the slope formula. In this case, you don't need to use the slope formula because it's on a graph. It might be easier just to count. All right, a couple of you missed this one. You remember what slope is? It's the measure, so to speak, of the distance from one point on a line to another point. And that slope is a ratio of rise, that's up and down, over run, left and right. So I could have just picked a point anywhere. I chose right here where I knew it was a whole number and say, okay, how many down and over do I need to go from one point on the line to another? Again, it could have been a point over here, but I'm going right here because it's at the corner of a grid and I can tell that I can get the whole number. So I'm after slope, and I need to go, if I go down 1 and 2 to the right, I'm back on the line. I'm back on a point on the line. So how would you represent that as a ratio? -1 over 2. Or just to illustrate, if I went the other way, if I went from 1 point and if I go up 1 and 2 to the left, I'm back on the line. Okay, so over here, going down 1, that's negative. So I got -1 over 2. And over here, I've got 1 over -2. Okay, these are the same thing, -1/2. All right. Any questions on that one? Andrew, I guess you're our spokesman. Oh, Annalise answered for you. Thank you. All right. So number 3 is basically the same thing. You can count up and over, and you should be able to get 3 over 4. All right, we had some trouble with 4 and 5, so now we're still after slope, but now instead of the line and counting, we're using the slope formula. Okay, change in y over change in x. Remember what the subscripts are. Subscript of 2 and 1, that's just telling you, to subtract your y and your x coordinates in the same order. So for like number 4, I could do 1 minus, rise over run, so I could do 1 minus 7 or 7 minus 1. I'm going to do 7 minus 1 because I want to stay away from negatives, or try to at least. So if I do 7 minus 1, I can't do 10 minus 1 to get my bottom number for my slope. I have to do 1 minus 10 because we're going to subtract in the same order. So 7 minus 1 is 6, and 1 minus 10 is -9, which we don't see that as an answer choice, but if we reduce, 3 goes into 6 twice, and 9 3 times. So our slope is -2/3. Any questions on that one? Again, a couple of you missed that one. All right, number 5, same thing, and now we've got to deal with fractions. So what I did is I did 9 halves minus -1. Okay, so that's a change in y. Oh, and then I got to subtract in the same order change of x. So I got -2 minus -5/3. And again, be careful not to lose track of your negatives. Okay. So now I got to follow my order of operations, do my arithmetic now that I've got everything set up. And subtracting is like adding the opposite. So subtracting a negative is like adding a positive. So that's why we have 9 halves. And we need a common denominator, so I changed 1 to 2/2. What is 2/2? It's 1. 2 divided by 2 is 1. And then I've got -2 minus -5/3. Double negative, again, that's a plus. And I'm working with fractions, so I need a common denominator. So I changed -2 into -6/3. So I have a common denominator with this fraction, this number. What is -6 divided by 3? It's -2. All right. So that becomes 11 halves over -1/3. Remember, the fraction bar means division. So this is the same as 11 halves divided by -1/3. But remember, if it's a fraction you're dividing by, you flip it over and multiply. So that's why you said, instead of seeing -1/3, you see I'm multiplying by -3/1. And that gives me -33/2 as my slope. Okay, we're good there? All right, let's go on then. Okay, horizontal and vertical lines. Okay, so you have to remember a horizontal line has a slope of 0. A vertical line, it has an undefined slope. Does the equation represent a direct variation? Remember, direct variation equations are in the form y is equal to kx. If so, find the constant of variation, which is k. So what I'm going to do is I'm going to put it in this form. I'm going to manipulate my equation and see if I can put it in this form: y is equal to kx, meaning y is equal to x with some coefficient. So I just try to get y by itself. I mean, you can, you should be able to recognize this as it is as y equals kx, but just in case, all right, I just divide, both sides by -3, and I have y is equal to -5/3 x. So that is in direct variation form, or it is, direct variation, meaning y varies directly with x. And what is the constant? The constant is this coefficient here represented by k. So we look at the coefficient, it's -5/3. So that is what the constant is. Okay, so same thing with number 9. We're going to put it in y equals kx form, which is y equals 1/2 x, and then what's the constant? The coefficient, which is 1/2. Okay, with number 10, suppose y varies directly with x. So that means that's you need to recognize that phrase as something dealing with that. That's a direct variation relationship. Y varies directly with x. It means y varies, or the value is going to vary depending on what x is. Okay, and then any constant. So y equals 10. So y equals 10 and x is equal to -3. What direct variation equation relates x and y? Okay, meaning we need to find that constant, that whatever x is, you're going to multiply it constantly by the same number to get you y. So we need to solve for the constant, and then once we have that constant, we can see what y is going to be when x is equal to -1. So we'll use the value, we'll take y equals kx and we'll substitute y with 10 and x with -3 and solve for k. Okay, so I substituted y with 10 and x with -3, and that's the same as this. So then I just need to solve for k by dividing both sides by -3. So k is equal to -10/3. And then at that point, I've got my equation now. Y is equal to -10/3 x, and I can substitute x with -1 to find out what y is going to be when x is -1. And so you got -10/3 times -1, that's a positive 10/3. Negative times a negative is a positive. All right, any questions on 8 through 10? All righty. Suppose y varies directly with x. So then we have a y equals kx relationship. What direct variation equation relates x and y? Okay, so again, we need to, just like we did number 10, we need to solve for, so we'd have 19/3 is equal to k times 4/5, and we need to solve for k, and then once we solve for k, we can get our equation and substitute x with -7/6 and see what it would be, see what y would be. Okay, so when we solve for k, we get 95/12. So we have y is equal to 95/12 x. So when we substitute x with -7/6, we get -665/72. Okay, I don't think anybody missed number 12. That's B. Number 13 is A. Another direct variation. Except y, we have n, and instead of x, we have h. Looks like. Okay, number 14, does y vary directly with x? Okay. And we find, that it does. Okay, so we could just solve, we take each one of these cases, 11 divided by 8, does that give me 1.375? 22 divided by 16, 33 divided by 24. We see we have the same constant. So they would vary directly. Okay, somebody missed number 17, so take note of that. Make sure you got that one right. Okay, so I think this is where I got a little ahead of myself as far as asking you this before we went over this, but we're going to go over it anyways. And then if somebody will just let me know, hey, will you eliminate these type like number 19 and 20 because I'm not ready for it, and then I'll take them off the test. Okay, so just let me know. That I'll put the responsibility on you in case I forget. All right. So again, if you're not, after we go over number 19 and 20, and I don't know if there's any more like that. You know, just if you're not comfortable with them and you'd rather wait till you get the lesson in chapter 5, then just let me know. All right, so write the slope-intercept form in the equation for the line. So we have to recognize slope-intercept is y equals mx plus b, and there's two values that you need to write an equation in that form. You need to know the slope of the line, and you need to know where it goes to the y-axis, the y-intercept. Okay, so in this one, we can tell where the y-intercept is. It looks like it's at a half. We would want to check ourselves to make sure. But I could just use the 2 points to get the slope. Okay, I can either use these 2 points or I could actually even count. You know, here's a whole number, here's a whole number. So we're going up 2. So that's the top number. And we're going, if I go up 2 and over 1, 2, 3, okay, that doesn't look right because the correct answer is saying 5/8. Let's see, 1, 2, 1, 2, 3, 2/3. So those must not be whole numbers. So let's go ahead and check it with our slope formula. So I'm going to do 3 minus -2. All right, changing y, we're changing x, subtracting the same order. So I got 4 minus -4. This is a -4. So that's 5/8. Okay, so our slope is 5/8. All right, and then all the y-intercepts are the same. So that's 1/2. Okay, but again, let me show you what we would do to get the y-intercept. So I have m, and then these points, these x and y coordinates, are values. You know, this y and this x, they represent an x and a y ordered pair. You know, they represent the x coordinate and y coordinate of the same point. Okay, so what I can do is I can take an x and a y value of a point and plug it in to this form along with the slope and solve for b. So for example, I'm going to substitute this y with 3, and then the slope is 5/8. I'm going to substitute m with 5/8 times x. So the y is 3, x is 4. So I'm going to substitute x with 4. And then I don't know what b is. That's what I'm solving for. Okay, I could have used this xy coordinate. I could have used this xy coordinate. I could use any xy coordinate for a point on the line to substitute in here to solve for b. So when I multiply, I've got 3 is equal to 5 times 4 is 20, 20/8 plus b. And then I'm going to subtract 20/8 on both sides. So what I have is I'm going to make this 3 where I have a common denominator. So that's going to be 24/8. Okay, 24 divided by 8 is 3. So I've got 24/8 minus, I'm subtracting 28s on both sides. And I've got 4/8, which is equal to 1/2. Okay, so the y-intercept is 1/2. So now I have the two values that I need to write my equation. Y is equal to 5/8 x plus 1/2. Okay. Anybody want to tell me right now no, I don't like this. Will you save it for Chapter 5 test, or anybody want to, at that point, they know they are, or do they want to take a little bit to look at it? Okay. All right, I'll save it for Chapter 5. All right, we're running out of time. We got 10 minutes. So number 20 is a similar situation. And we're eliminating that for this test, so we'll save that for later. Okay, number 21, we did fine on. That was just like number 2 or 1. Again, you can come up with 2 points and see which line has those 2 points, or you can use slope and y-intercept. Okay, so 22 is B. Okay, somebody missed number 25. You need to take note of that. The situation here is it's just not in slope-intercept form. So, oh, they're not asking for that. They're just asking for the x-intercept and the y-intercept. All right, so the x-intercept is going to be where y is equal to 0, because you're not going up or down off the x-axis. So if I substitute y with 0, I get x is equal to -4. Okay, so the x-intercept is at -4. The y-intercept is going to be when x is 0, because I'm not going left or right any. So when I substitute x with 0, I get -7/5 y is equal to -4. So y is going to equal -4 over 1. I'm going to multiply by the reciprocal to get y by itself. So that's times -5 over 7. Negative times negative is positive. 4 times 5 is 20. So we have 20 over 7. All right. So 26 is D. Again, probably the best way at this point to find the right graph is find yourself 2 points that are on the line. Let x equal 0, substitute. Let y equal 0, substitute and solve. And find those 2 points that you end up with on the graph. Okay, so I think all of you missed number 27. Again, what I'm showing here is what you decided to kind of wait on. Well, no, you've done this. You could put in slope-intercept form and then find this would be the y-intercept. So you're looking for something that looks like -6/7, which would be a little less than 1. And that has a slope of -12 over 7. Okay, so you can eliminate these because they don't go through the y-intercept at -6/7. And then you can eliminate this one because it's a positive slope, but you see here you have a negative slope. Okay, so again, you could do it this way, but you can also just stick with finding your x and y intercept and see which line goes through the x and the y axis at those 2 points. So, where am I at when I substitute x with 0? Where am I at when I substitute y with 0? All right, so again, all of you missed number 27. Any questions on number 27? Okay, number 28 is A. 29 is B. 30 is D. Whoops. Okay, this is where you guys are having trouble with domain and range, 31 and 32. With you remember what range is? Okay, so here I have my equation y equals x plus 1. My range is all the values for y. My domain is all the values for x. So they're saying, you know, you're limiting your domain from -2 to +2, the integers, no fractions or anything. And they're saying, okay, when you have these values for the domain, what is your range? So I would take y is equal to x plus 1 and substitute x with -2. So when x is -2, I've got -1. Y is equal to -1. Okay, so that's one value for the range. Okay, and then I would substitute x with -1. I have -1 plus -1, and that's 0. Substitute x with 0, and y is equal to 1. Substitute x with 1, and y is equal to 2. Substitute x with 2, and y is equal to 3. So that's your range, -1, 0, 1, 2, and 3. That's the range that you're looking for. Or that's the range for the given domain. Okay. And then finally, number 32. Let's take a look at this. All right, the scissor lift is a machine that can lift and lower a platform for people to work from various heights. The maximum height a certain scissor lift can reach is 252 inches. So you've got your, I didn't know I had my highlighter here, but you got your scissor lift. And so the max height is 252 inches. Its minimum height is 48 inches. The lift can raise the platform at a rate of 3.5 inches per second. The height of the platform after t seconds is given by this function here. What are the domain and range for the lift? Okay, so remember, with a function, your range is your y or your h of t or f of x. That's the values. Those values are the range. That's your dependent variable. And then your domain is the values for the independent variable. Okay. So the function represents height, h of t. All right. We know what the minimum height is. That's 48 inches. Okay, so let's look at range first. Okay, so the range is the height. Its minimum is 48 inches, and its maximum is 252 inches. So h of t, the height, which is the range, or the values for this are the range. So h of t has to be less than 252, less than or equal to 252, and greater than or equal to 48. Okay, so again, this function represents height. That's the dependent variable, and they're asking for the domain and range. I started with the range first. It's the most direct. It's going to range in height from 48 inches to 252 inches. That's the range. What's the domain? Well, the domain's not going to exceed anything other than when t is 48 or 252. So what we have to do is, again, t is time. That's a rate of height. How high it gets at t number of seconds. So if we're going to start at 0 seconds. We're not going to have a negative time. So we know that t has to be greater than or equal to 0. And then all we have to do is, okay, we know our maximum height is going to be 252. So let's just solve for t to find out what the time's going to be when we're at 252 feet. So I substituted in this function, I substituted h of t with 252, and I solved for t. So that's going to be my maximum domain, 58.2 seconds. All right, so I'm getting ready to get kicked off. The time's getting ready to run out. So here's your domain.